assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
All right, so here we're going to take a look at a two-part question about the element astatine. So first of all, anytime we get a question about an element, it's a good idea to go ahead and locate it on the periodic table. So astatine, which has the symbol At, is found in group 17 toward the bottom of the halogens. This group also contains more well-known elements like fluorine, chlorine, bromine, and iodine, but astatine is who we'll be focusing on today. So the first part of the question asks, is astatine more likely to be a solid, a liquid, or a gas at room temperature? And so what I first want us to do is take a note about the characteristics of each of these states of matter. So when you have a solid, the particles are very close together, while on the other hand, gas particles are very far apart, and the liquids are kind of somewhere in between. Now, if we had to kind of rank these different states of matter in terms of their attraction, we would say that particles in a solid state are more attracted to each other, while particles in the gas state are much less attracted to each other since they're so far apart. And so what this question is wanting us to realize is what are some things that cause these types of attractions? One factor that's at play here is the size of the atoms. What we find is typically the bigger the atoms are, the more they can interact with each other, which increases the amount of attractions. If you've studied the chapter on intermolecular forces already, this may remind you of what's called London dispersion forces. So that's exactly what's going on. If you haven't gotten there yet, then just know that bigger atoms means better attractions, okay? So if we go back to our periodic table here, let's think back to the trend on size as we go down a group. So what we may remember is that the atoms tend to get bigger as you go down a group. They're adding new electron shells and kind of expanding outward. So astatine out of the halogens would be much larger than the others in those group. So if astatine is a large atom, it's going to have lots of attractions and so most likely be found in the solid state, which it is. So second, we get the question, well, what about a reaction? Would astatine be likely to react with sodium? So sodium is in group 1, and we could say yes, because sodium we know is very reactive. And what makes them a nice pair is that sodium is interested in losing one electron, while astatine is interested in gaining one electron. So if we put them together, we want to kind of predict the formula of the product. So if we start with sodium and combine it with astatine, what might we find? So we know that because we're combining a metal and a non-metal, that we're going to have an ionic compound, which means we need to balance out the charges to create our formula. Because sodium is in group 1, when it forms an ion, it will lose one electron and take on a +1 charge. Astatine, on the other hand, because it's in group 17, it's one away from having a full shell. So typically, it will gain one electron, which gives it a -1 charge. So we can expect sodium to have a +1 charge and astatine to have a -1 charge. Those charges, thankfully, are already balanced out, so that means our product will just be a 1-to-1 combination of those elements. So Na followed by At. All right.